Hello. We are the 2019 Amazon Robotics Scope Team. My name is Min. This is Nicole. She'll be my co-presenter today. We have 3 more members on the team, Arpan, Cedric, and Kevin. We want to give our special thanks to our faculty advisors, Sam, as well as our company liaisons, Tim and Guan, for all the support and the help you've provided with us for an entire year, as well as Amazon Robotics for bringing back interesting challenges year after year. So, in this very moment, there are hundreds of thousands of items sitting in an Amazon fulfillment center waiting to be delivered to your home. With a click of a button, magic happens, and 2 days later, you'll have a box waiting on your doorstep. But for this to happen, there's a lot that goes behind the scenes. That's where Amazon Robotics comes in. Amazon Robotics is Amazon's most prominent research and development center located right here in Massachusetts. Amazon Robotics enables Amazon to deliver a smarter, faster, more consistent customer experience through automation. To keep up with the growing customer demand in the e-commerce industry, automation of warehouses seems like a very natural path for many companies to pursue. The industry is tackling automation through various types of technologies, as you can see in the photos. Some companies are looking into automating entire warehouses, while some companies are pursuing autonomous robots to move products around a warehouse and assist workers. So before we get into the technicalities of our project, let's take a moment to step back and consider the broader context. Why are we trying to automate warehouses? What are the motivations, larger implications, and the trade-offs? This is not a simple question, nor is there one clear answer. For example, one perspective to this question is that automating warehouses is a necessary means to meet the demands of the growing e-commerce industry without having to build larger warehouses filled with more human workers doing mundane, repetitive tasks. On the other hand, others raise a concern that automation is putting people with lower educational backgrounds that cannot find alternative jobs out of work. At the same time, research has indicated that the e-commerce industry may be a more environmentally sustainable industry than the traditional commerce industry. As engineers, we acknowledge the importance of the question and continuously reflect on the potential implications of our work, while recognizing that these are deeply complex issues. Now, I want to introduce to you the challenge that Amazon presented to us at the beginning of the year. As we mentioned, there are thousands of items waiting for your click in an Amazon's warehouse. Those items live in yellow-friendly totes, and they need a way to get around that warehouse to make it into that box on your doorstep. That's where our project comes in. We needed to come up with a robot that could store and fetch totes on demand.
So, when we were designing our robot, we used these questions to guide us. First, how will the robot navigate and tell where it is in the warehouse? Then, how will the robot actually physically interact with the totes to get them to where they need to be? With these questions in mind, we came up with a set of software and hardware solutions. First, to address the navigation question, we'll talk about software and firmware design. After much deliberation, we decided that the best solution for mapping out our warehouse was with a system of RFID tags and magnetic tape. RFID tags are those white cards that you see up there, and basically the way those work is that they're always giving off some unique signal. Each one has its own. As the robot drives over those cards, it's able to read the card, get the signal on the card, and know exactly where it is in the warehouse. The magnetic tape is exactly what it sounds like. It's basically just a strip of magnet taped to the floor. And what that does is it gives us a very easy line for our robot to follow using that magnetic sensor pictured up there. We decided to go with this solution as opposed to others, such as just regular black tape and a light following sensor, because it's more robust and will wear down less over time. It also requires much less accuracy, which means that errors are very unlikely to occur when the robot is following these. To drive our robot around, we just decided to keep all the complexity in a cloud, which would plan the robot's path and give the robot simple commands to follow. In terms of hardware, we started with a simple off-the-shelf drive base and modified it to drive with 2 wheels. The reason we chose to do this is because we like the original drive base for its compact footprint, and by making it a 2-wheel drive, we were able to give it the ability to spin in place accurately and without losing position. We put some thought into how to store and manipulate the totes, and we decided to follow an existing Amazon robot model. That is, a robot that is able to pick up the totes from the bottom. So we further adapted this drive base to have a lift mechanism, which you can see here. Now, in order for our robot to lift the tote from the bottom, it needed some way to get underneath it. So we designed these special platforms, which we called underpacks, which would allow the robot enough space to get underneath the tote to pick it up. Notice that the underpack fits snugly under the tote with that lip going around the outside. This means that it's impossible for the tote to go sliding off of the underpack while in transit. However, we needed some way to keep the underpack on the robot itself. That's where this mechanical alignment system comes in. As you can see, on the underpack, we put a system of slots, and on the lifter plate on the robot, we put a set of nubs. As the robot lifts up, the nubs interact with the slots, and it locks the underpack in place on top of the robot. The benefits of these features are twofold. First, they help make sure our robot is able to move around the space without the underpack sliding in ways that are going to be detrimental. Second, it also serves the purpose of allowing our robot to pick up the underpack reliably, even if there's misalignment when the lifter goes up. Here you can see a video of our final deliverable. As you see, our current robot is able to go to a location where a tote is, following that magnetic tape, align, pick up the tote, and then follow directions given to it by the cloud to bring that tote to wherever else in the warehouse it needs to go. So, what is our impact on Amazon? We have been able to provide them with a small, scalable proof of concept prototype for upcoming innovation. Over the course of our design process, we produced trade studies that will aid in future work being done in this area. And finally, and most exciting to our team, novel solutions we came up with to the challenges that were presented to us will be further researched and patented. So thanks for listening, and we hope to see you at the poster session.